Hi there. So today I'm going to cover section 2.2. You'll notice that this section is very similar to the section 2.1 that we did last time, the inputs and outputs. Now we're just going to use formal name. Okay, what this section is domain and range. Okay, again, I claim that there's really nothing new here. We're just going to be looking at things a little bit differently and again with different terminology. So the inputs that we referred to last time in our function are actually our domain. And the outputs, the values that the function takes on, are called our range. And there's different ways to talk about what your domain and range are, and it really depends upon what information you happen to be given. Okay, so let's first talk about when we're given a graph. Okay, well, the thing to remember is as follows. The domain are our inputs. Those are our independent variables. So the domain corresponds to our horizontal axis. And yeah, I usually think of that as my x-axis, but again, sometimes we talk about functions of time, and therefore time would be our horizontal axis. And our range are our outputs or our function values, so those correspond to our vertical axis. Okay? Keeping that in mind, let's look at a couple of examples here. Okay? This first example, we're going to assume that the entire graph is shown. So this is 2, that's 1, this is 6, and that's 3. Okay? What I want us to do is provide the domain as well as the range. Okay? So when you're looking at these, what you want to ask yourself when dealing with the domain is what values on our horizontal axis do we take on? Well, we see that the graph starts here at 2 and it goes all the way until 6. Okay, notice I have brackets. The reason why I have brackets is because we actually take on those values. Another way we could put it if we wanted to is x is between 2 and 6. Okay, now what about our range? Well, our range are our function values or our y values. Okay, I always start down here. What's the smallest y value we take on? That's 1. And how big do we get? We get as big as 3. And again, you could put y is between 1 and 3. Okay, now on the other hand, what if our graph looked like this? I'm not going to make it too complicated, but let's go here to here. I'll label everything in a moment. Okay, doesn't this one look fun? Notice this is an endpoint on my graph. It stops here, but you see there's the arrow there saying that, hey, we keep going. Okay, so given this graph, again, I could ask you the domain and I could also ask the range. Again, with our domain, I always start as small as possible because again, when we list things in notation like this, in our interval notation, you always put the smaller number to the left and the larger number to the right. So the smallest we are on our horizontal axis is -2. So then the question is, how big do we get? Well, we keep going, we keep going, we keep going. Oh my gosh, we're going on forever. So we say it goes off to infinity. Notice I have a parenthesis next to my infinity. Again, because infinity is an idea, it's not an actual number. An equivalent way of writing this is you could say x is greater than or equal to -2. And now let's look at our range. Well, how small do we get? The smallest we are is -3. And notice we keep growing, so we would put -3 infinity. Okay, again, you could say y is greater than or equal to -3. So given a graph, I can certainly ask you what your domain and what your range are. Okay? Now let's talk about how to tell given a formula. Okay, so given a formula, let's talk about this. First, let's talk about our domain. Okay, we're asking what inputs are allowed. Well, I claim we have exactly 2 limitations when we're dealing with our functions over the set of real numbers. Okay? One limitation is you can't take the even root of a negative number. Okay? In particular, we deal with square roots more than any other root. Okay? But any even root, you cannot have a negative number underneath that radical. Why? Because if you take any number, positive or negative, and raise it to an even power, it's always going to be a positive number. Okay? We can take like the cube root of a negative number, but not an even root. Okay, and then our second limitation is we cannot divide by 0. Okay? So if you're given a formula and you're asked to find the domain, what you need to do is deal with both of these 2 limitations. Okay, those are the 2 questions you need to ask yourself. Now the range, and honestly on any test, I'll ask you the range on a graph, but in a formula, I honestly won't be asking this. These can be more difficult given a formula. So you have to either analyze the formula algebraically, or what I would recommend is use a graphing calculator to graph it, or you can do it by hand, and then answer it using the graph. Okay? Now I'm going to go through a bunch of examples, because these are the ones that require the most work. All right, so the first example for all of these guys right now, what we're going to do is find the domain. Okay? Find the domain. So your book doesn't even ask for a lot of ranges when it comes to the formulas either. So here's our first guy. 1 over x plus 3. So we have to ask ourselves 2 questions. Do we have to worry about taking the square root or an even root of a negative number? I claim no, we do not. There is no root in this question. Okay? So we're all good with the first guy. The second one, do we have to worry about dividing by 0? Yes, we do. Okay? Because we do have a fraction. So what I would do to find my domain is I would set my denominator equal to 0. And I think you will grant me that's where x is -3. Okay? So what I would say is my solution, if I wrote it, would be x can't be -3. Implicit in saying this is we're saying it can be any real number except negative 3. We could write that as okay. We can go from negative infinity to negative 3. Notice I have a parenthesis because we can't take on that value. Or negative 3 up to infinity. This is equivalent to saying x can't be negative 3. Whichever way that you're used to writing it is acceptable for me. All right. So what if I want us to find the domain of this one? 1 over x squared plus 2. Again, I have to ask myself those two questions. I claim I don't need to deal with the first because I'm not taking any square roots or fourth roots. But I do have to deal with the second one. I have to worry about dividing by 0. So again, what I'll do is I'll take my denominator and set it equal to 0 to find out where those value or values may be. Well, in order to solve this, I move my 2 over. And then I continue on to take the square root because I need x. But can't take the square root of a negative number. In fact, the domain here are all reals. There's no real number that you could plug in here to get your denominator equal to 0. Again, because, yeah, the square root of x squared is x, but this would be an imaginary or complex number, and we're not dealing with those. Okay? So, what if now we want to find the domain of... Oh, and again, if you want to say all reals, you could write that out in English, or you could say, oh, we could go from negative infinity to positive infinity. What if now my function was x squared plus 2x plus 7? And I asked for our domain. Well, again, we go through our questions. Number 1, do we have to worry about taking an even root? Nope. Do we have to worry about dividing by 0? No. So, since there's no restrictions, again, our solution here is all real numbers. All right. What if I have this? Suppose g of x is the square root of x minus 7. Here I do have to worry about the first, okay? No, I do not need to worry about dividing by 0. There's no division going on here. But I do need to worry about taking the square root of a negative number. I think, or I hope you'll grant me, that this thing under my radical, whatever I'm taking the square root of, has got to be greater than or equal to 0. Okay, we're allowed to take the square root of 0, and we're allowed to take the square root of any positive number. And the way we write that mathematically is it's got to be greater than or equal to 0. And this is an inequality we can solve. So our domain is x must be greater than or equal to 7. Now, what if I have this? What if I have 1 over the square root? Let's just mix up our number and our variable a little bit, of 9 minus x. All right, well, now we have to worry about both, okay? I need this thing under my radical to be positive. So initially, if this was just all alone, you would say that 9 minus x has got to be greater than or equal to 0. But not only does this have to be greater than 0, it can't be equal to 0. The reason why is because it's in your denominator. So what you do is you take whatever's under your radical and say, oh, it's got to be positive. Okay, again, the difference here is I could have it equal to 0 because this was up in my numerator, but now that it's in my denominator, I cannot. All right, I would just add x to both sides. And so what we would say is, oh, x must be less than 9. Now, some people prefer to write it in that order, and so these say the same thing. Okay. What if I wanted us to find, guess there's not really too many interesting things here, but let's do the square root of 15 minus 4x. All right. Well, what are our restrictions here? We don't have to worry again about dividing by 0. The only thing we have to deal with is the fact that this mess under our radical has got to be positive. Okay? And again, we solve this just like we solve equations. The key thing to remember is when you have an inequality, if you multiply or divide by a negative number, you've got to flip your inequality sign. Okay? So, I can add 4x to both sides. And then to get x alone, I can divide both sides by 4. So I have x is less than or equal to 15/4. Now, one little quick comment that I would like to make is this. When you have a function equal to just the square root of something, okay? Once you take the square root, everything's positive when we graph it because we only consider the principal square root. So I could tell you that for this guy and for, I think we had like x minus 4 or something like that, the range is that y is greater than or equal to 0. Okay? Because I claim if I plugged in 15/4 here, I'd be taking the square root of 0, which is 0. That's as small as we can get, and then you just get bigger from there. Okay, so one more type of formula question. What if now I would like us to give the formula for a function? Let's give the formula for a function whose domain is as follows. X is less than -5. Okay, so when you see a domain where x is less than or greater than, what that should indicate to you is that you're going to have a radical. Okay, if you just say, let's find the a formula of a function where x can't be 5. If it can't be one value, that tells you you got to deal with dividing by 0. So it would look like this, 1 over x minus 5, or you could actually have any number up here, okay? But when you have an inequality, what you're dealing with then is dealing with taking the square root or the 4th root or anything. I mean, there's infinitely many formulas that we can put in here. So I think it's better to say give a formula for a function, okay? So what do we have? We need x to be less than -5. What I would suggest you do is kind of do the reverse process of what we have been doing. Let's move everybody to one side. Okay? If I move this -5 over, the way I would do that is I would say x plus 5 is less than 0. Okay? Why? I just added 5 to both sides. Okay, how would we find this function? Well, again, when you're taking the square root, will this actually work? Well, no, you need things to be greater than 0. Okay? So, notice now while we normally move our variable over, we want things to be greater than 0. How can we flip the inequality sign? Well, one thing we could do is we could multiply through by a -1, and that would do it. Or we can take this guy right from the get-go, and instead of moving my 5 over, we could move my x over. Okay, -x minus 5. Okay, so this is the inequality that we started with. Okay, we can only plug in values that are less than -5. So the way we can look at it is, well, if we want to write it as a function, let's put it greater than 0, and now we can say that. Okay, and again, you can check that this will in fact give you all of the values that we're interested in. All right, so the last type of situation that we're going to look at here is in the context of a word problem. So let me erase the board here. Okay. All right, so in the context of a word problem, what you have to do is look at the constraints of the particular situation that you're in. So let me say, look at the constraints of the situation being modeled. For example, let me write this guy down. This says the following: a restaurant is open from 2 p.m. to 2 a.m. daily. It also tells us that a maximum of 200 clients, I never thought of people visiting restaurants as clients, but I guess technically that would be the case. A maximum of 200 clients can fit inside. If f of t is the number of clients in the restaurant t hours after 2 p.m. each day, what we want to do is give a reasonable domain and range. Okay, so the first thing to figure out is what is our domain and what is our range. I'm not asking for the answers, I'm just asking in terms of what they are in the context of this problem. Notice we have our function defined as f of t. So our function, in other words our range, is the number of clients. And notice our input or our domain is the number of hours after 2 p.m. Okay? So let's ask ourselves, what possible values for t do we have? Well, if t is the number of hours after 2 p.m., t can certainly take on the value of 0 because that's 2 p.m. And then for how many additional hours is it open? Well, it's open for an additional 12 hours. So in this example, our domain is from 0 to 12. Now let's talk about our range. Well, our range represents the number of clients. In other words, the number of people who come in to eat. What's the smallest number we could have? Nobody. And what's the largest that can fit in the restaurant? 200. All right. Let us do one more example here. So for this guy, T stands for our time in seconds, and R of T is a rate, and the rate is given in gallons per second that water enters a reservoir. And here we're actually given our function. R of T is 800 minus 40T. Okay, now we'll get to the domain and range in a second, but what I would like to do is point something out. Notice, if I just ask you to find the domain and or range of this function, okay, what would you say? Well, you would say, hey, I don't have to worry about taking the square root of a negative number, and I don't have to worry about dividing by 0. Therefore, my domain's all real numbers. Okay? The thing is, you have to interpret it in the context of the particular word problem you're dealing with. Okay? Now, my hope is that a light bulb is going off in your head and you're like, oh, Lauren, that's the equation of a line. My y-intercept is 800. My slope is negative 40. Okay? Being able to identify what type of function you're dealing with is really important. So, what we want to do here is we want to evaluate R of 0, R of 15, and R of 25. And we're also going to interpret what we get. Okay? So, R of 0, well, what does that mean? Everywhere where we see a 0 in our function R, or everywhere, where we see a T in our function R, we're going to replace it with 0. So I think you will grant me that's 800 minus 40 times 0, which is simply 800. Okay? Remember, this is in gallons per second. So what this is saying is initially, water is entering the reservoir at a rate of 800 gallons per second. Okay? Next, let's evaluate R of 15. Well, that's 800 minus 40 times 15. And what do we get here? We get 200 gallons per second. So what this is saying is 15 seconds later, water's entering our reservoir at a rate of 200 gallons per second. Last but not least, we can plug 25 in, and what we're going to have is 800 minus 1,000, and we're going to get negative 200 gallons per second. Well, what's going on there? The reservoir is full, and now it looks to be leaving that reservoir. Okay? So, a reasonable question that comes to my mind is as follows. When is the rate that water enters the reservoir equal to 0? Is that something we can solve? And I claim yes. Okay? Now we want to know when, we're looking for time, is that rate, in other words, 800 minus 40t equal to 0? And this is somebody we can solve. Scoot your 40t over, and then divide both sides by 40, and you get t is 20. So at 20 seconds, the rate at which water enters our reservoir is 0 gallons per second. So this answer up here makes sense, because after 20 seconds, water is no longer going to be entering our reservoir. It's going to be leaving our reservoir. Okay, so let me ask you this. If we only want to talk about water entering the reservoir, when does that happen? Well, that starts at 0 seconds. And at what value does water quit entering the reservoir? At 20 seconds. Okay? Now, what if I asked us to find the range? Well, since we have the domain, and it can go from 0 to 20, what you could do is plug them into your function to see what the corresponding outputs are. Okay? Now, at first this is not going to be written in order. Notice that when t is 0, we start out with 800 gallons, or 800 gallons per second entering our reservoir. And when t is 20, it's at 0. Okay? Notice I switched them around because notice this is a decreasing function. So when we put in our smallest value of our domain, we would actually get the largest value of our range, and vice versa. All right. Well, that concludes section 2.2. Have a ball.